Hi friends, welcome back. I think we started off with the movie exploration dataset. So the same concepts apply. So if you see here, if you don't want to write it out, I have just put a flag here. You can change it if you need to. So then, so this kind of puts out a lot of these relational kind of tables out. So then this is the main movie lens dataset. So this is the main table, which will have all the movies data. So basically, all this is doing is taking out any column that is not required, or any column that is actually complex in nature, and it is taking it out and shred end up saving it as a data set in a Parquet format. So if you see, notice this code, it does. It only selects a subset of the columns. So if you see this piece, it only selects certain set of columns. So that way we don't have to worry about keeping all those complex JSON structures in Postgres, and just bloating the data set. So moving on to the same concepts apply to credits. If you go to the credits, remember we had seen that it has like an ID of the movie and all the credits and the cast. So same idea here. We create our own data structures, the cast schema and the credit schema, and then we read that JSON. We explode it with from JSON explode function plus from JSON function. So these two functions will work together to take the JSON array and shred that into maps, and then for each row that is there in the JSON array, it actually creates a new row. So that's the explode function. For every element of the array, it explodes it into multiple rows, and from JSON is what takes the data that is inside the column in the JSON format, and then it actually shreds that into a map structure, actually an array of map structure, and then you can actually pull out specifically what columns you want. So if you see here, cast data is the with column statement. So that is so after we do the explode function, the cast data column will be created in the data set, and that will be like a map. So you can actually do a dot convention and pick up the exact columns that you need. So we don't want to have all these special characters in the table structure, so we rename them after the dot as operator. So this will result in the output that is what we care about. So this writes out the cast, and then it writes out the crew and stops. So the same idea again we apply into keywords. So keywords also the same thing. It's an array of JSON structures. Another thing I want to mention here is, right, there are some rows in the dataset that have commas and quotes present inside the data. So when you just read without these two options, option quote and escape, it will actually create it'll understand the comma as a separate column, and you will see a lot of kind of messed up data. So if you look at the repository and you go and look at the exploratory analytics, you will see that issue. So to prevent that issue, you need to do the quote and escape, and then you need to read that data. So once you read that, then it will actually show you the exact JSON. Each column will have exactly the JSON, and it will delimit correctly. So that's one aspect that I want to tell. Same idea here also. We explore the data, then we do the from JSON, and then we print it out and write out the data. Right. So after you run this, maybe you can even run this locally. We don't have to provision a data set VM or anything. Um, so we can even this Spark code, check it out, and then you can actually install Spark on your local laptop, and then you can run this directly. So once you run it, right, of course you need to pull the Kaggle data set and then put it on the right directory, and then you can run it. So I have given some instructions on, and these are all based on my laptop. So you have to change it based on how you set it up. So you need a JDK 11, you need to install that, then you set up the path, and then in my case I have Spark and Cvenky splash Spark bin. So you can change this to whatever yours is, and that is for the Maven builds. And this is a Spark home, right? So you set up all this, and then you can actually set your path, and you set up your Hadoop path, and then you can cd to this directory where they checked out the Spark examples code, and you can do the Maven clean package to actually build the jar. So once you build the jar, right, so you can actually do the Spark submit with a local pointing to the master local. So the whole Spark program runs inside your laptop. So if you have a pretty decent laptop, 8 to 16 gigs of RAM, this thing should run with no problem. So if you don't want to spend money on Azure and you want to do everything locally for now, that's an option too. So you can do that. So submit, master pointing to local. This is the actual. These are the two individual programs we call, and we pass the see the movie lens data set, right? The movie metadata CSV, and writing CSV as input. So this goes through the shredding process, and then it will create a lot of files. So once you run all those programs, so basically you will end up with a structure like this. So it will have like each movie lens. This is a master folder. In that you will have a cast, a crew, a collections, a genre, keywords, movie collection, movie genre, movie keywords. So think of this as like your relational table structure shredded. Cast will have all the cast data, and like collections will have the collections data, and the link between the movies and the collection will be in the movie collection data set. So think of this as three different tables in the relational data set database. Movies will be your master table. Movie collection will be your join, like a link table, and the collection will be your the collection side on the other side of the table. So this is pretty much what you will see. And if you open up any of these, you will see that it has been loaded as a Parquet file. And this is output from Spark. So this you can use to actually load either uh, into the Postgres database, or you can push it directly into ADLS. So if you go back, the last piece that I want to cover is the load movies into Postgres. So this one actually reads your uh, uh, the movie lens data we just created, and then you can actually change this to point to a even local. Like I'll probably demonstrate that. Like I'll run Docker, set up Postgres, and actually point this to load into my local Postgres database. That way you don't have to spend pretty much any money. So you load Spark, you load Postgres in Docker, and you just fire this program. It'll run at least the first journey without even setting up your data science VM. So this takes the data, and then if you want to bypass certain sections, you can obviously take this and then put it anywhere you want. But all this is repetitive code. It just loads all these tables. Then it goes through everything, and then the biggest table is the ratings table. So I have kind of made it put it in the last. So this is the 26 million data set, so it will override the table. So and then I have set up all these truncate tables override, so you don't have, even if you run this like multiple times, it will basically reload the data over and over again into the Postgres database. So that is pretty much it for this video. So if you kind of watch the next one, you will see that we set up the data science virtual machine. There's no audio on that. At least you can kind of follow through. And then we will actually run the Spark programs, and that will actually take the Kaggle data, shred it into this structure, and then run this program to actually load it into the local Postgres database. So this Postgres database also provisioning and all that is through ARM templates. So if you see the repository, you will see ARM templates. You can fire them. There's a PowerShell script associated with each ARM template, and you can just fire those, and then it will be ready to provision the data. So we'll collect that, and then we can actually show the ARM scripts and all those things in the next video. Thank you.